Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en wie zit hier weer naast mij?
Jan Stomphorst, ACC ICT, Solutions Architect. Nog meer?
Nee, podcast host, barbecue-meester.
Barbecue-meester. We zitten weer op KubeCon.
Weer op KubeCon. Voelt best wel lang geleden dat we zeg maar zo gezeten hebben.
13.000 man op KubeCon. Maar ga ik nog wel een paar keer zeggen?
13.000.
Ja. Nou.
Oké.
Dus,
nou,
let's introduce our guest.
Let's not keep him waiting.
No.
Yeah? Switching from Dutch to English is always like a thing. Neil Cresswell, CTO from Portainer, if I'm correct.
CEO.
Oh, CEO even. Okay, right. Welcome, Neil. And can you please introduce yourself to our listeners?
So I am Neil, CEO, CTO, co-founder of Portainer from New Zealand. So you need to excuse my accent. I'll try and make it sound international. But living in America these days. So yeah.
Nice. And how did you get started in the IT? What is your background?
I actually started in IT when I was 17, believe it or not. So I started out as a electronics engineer, fixing monitors and printers and power supplies, and moved. I got
really hands-on.
I got headhunted into IBM when I was 19. I was at IBM 13 years, and then went out working for myself.
Right.
So been a consultant and engineer all that time.
Cool. So you love working with your hands, right? And if you always like,
I always fix things.
You always fix things. Yeah, break things. Yeah.
So, and you started Portainer?
I did, yeah.
And what does Portainer do?
What does it do now, or what did it do when we started it?
Both.
so what did it do when we started it was a Docker UI at the time. I was running a public cloud provider up in Asia, and I wanted to offer Docker containers as a service, and this was my cloud provider UI for that service. Open sourced it, and it went crazy. So it was unknown, and then I think 3 months after we open sourced it, no intention to make any money out of it, right? Just open sourced it. 3 months after, we had 1 million users. 3 weeks after that, we had 10 million users. And I think about a year after that, we had over 1 billion downloads. So it went kind of crazy.
Yeah,
but
the world changed at that moment, right?
The world changed at that was 2016. Great timing. And 2020, we decided to try and make something of this. And 2021 is when we kind of started adding Kubernetes to it. So now it is a operator control panel. So it is a management tool to manage hundreds or thousands of Docker, Podman, and Kubernetes environments from one central place.
Okay, but I'm also interested. How did you become how did you become to the software part? But you told you were like more hands-on with the hardware. Where came the switch? Was that at IBM or?
I'm not a developer at all, so I can't code my way out of a paper bag. So I was a consultant, and so I spent a lot of time listening to CIOs talk about the problems they were having and coming up with solutions. And when I saw how much of a game changer containers were, and yet how complicated they were, I was like, okay, this is going to cause more problems than it's going to solve. That's not good. And then also I've had a lot of experience in operations. I was also a CIO for a while. And being responsible for basically IT's availability and cost efficiency for very large e-commerce companies is like, okay, you need something that's operationally efficient, that if it breaks, you can fix it quickly. You're not trying to find an expert. You're not running around trying to figure out cause versus effect. And how do you do that? You weed out all complexity. And so I partnered up with my co-founder, who is a developer, and said, hey, I've got this idea. How can we radically simplify this whole landscape? And he helped me code it, and then we scaled it from there.
Okay.
So yeah, I was more of a solution.
The visionary.
The visionary.
Solutions architect.
Yeah.
I know that job.
Yeah.
So This shows how old I am. I'm TOGAF certified, so the Open Group Architectural Framework. So I am an architect from back in the day.
Yeah, right.
So
Cool.
Yes, very, very much solution focused.
Nice.
But because I know Portainer from the tool to use when you used before Kubernetes, and when we used to run Docker. We don't run Docker anymore, but when we used to run Docker, so that's awesome. That made such a big flight, and that's also the thing you experienced, the power of open source.
Yeah, my biggest marketing challenge is in fact my brand. I did almost think about killing the brand and having a new brand, because you speak to anyone, hey, yeah, I'm from Portainer. Oh, you're that Docker UI thing.
Yeah.
No, we were $20 million of R&D ago. We're not there anymore. Now we're this multi-cluster management control tool. We're not what we were anymore. We're radically different. It's significant R&D, a huge engineering team completely transformed the product. It's the same name, but in no way is the product today what it was 4 years ago. In no way.
Yeah, there's some dissonance right there still. Yeah. So is it something like Rancher also? Because as I hear multi-management for cluster for management for multi-cluster environments or different solutions. Is it something
if people are familiar with Red Hat OpenShift Advanced Cluster Manager. So it's a multi-cluster manager. If you're familiar with a CNCF Open Cluster Management, or I can't remember the name of the other product. They've got two products that are trying to address this. It's just a way of saying, okay, here is a central control plane deployment, and from this point you can define policy, control, governance, RBAC, GitOps, observability, logging, everything. And you say, okay, from the one tool, you can deploy and manage across thousands. I mean, our largest customer is managing 120,000 environments from one Portainer instance.
Impressive, yeah.
So, yeah.
Is it a SaaS solution?
No, I quite against SaaS for running mission critical management systems. I'm not a fan of here are the keys to my house. Please be good. It's like this is the crown jewels. Whoever runs your Kubernetes platform, whoever has the golden keys, has access to everything. So it is a self-hosted piece of software you run inside your environment.
Just trust me, right? Just trust me.
Absolutely not. Don't trust me. Again, look at this last week. The absolute nightmare of Trivy.
Yep.
It's like, okay, no thanks.
No thanks.
So we are not SaaS. We actually run as a container, and you run us in your environment, and you've got complete control.
Nice.
Cool. You've got another project, and that's what sparked my interest. You've got Kube Solo.
Yeah. I have described this now. You might want to remove this later, but I've described Kube Solo as a brain fart. It was
That's the visionary part, right?
It was
the architects talking?
It was a completely crazy idea, and it's like, okay, so like Docker and Podman have their place, right? They're very good because they're super lean.
Yeah.
Except they're kind of gone now from an ecosystem perspective. Anyone who's shipping software, any third-party tooling, it's all now written for the Kubernetes API. But if you look at even the most lean and mean Kubernetes distros out there now, K3s, K0s, Micro K8s, they all realistically need a machine with more than 2 gig of RAM. You know, they will use between 700 meg and a gig of RAM to idle Kubernetes. And I'm like, well,
why is that?
Because Kubernetes is all these different parts. You've got Etsy there, or the quorum, and
it's big. It's big. Designed for
data center.
Bigger,
right?
Yeah, it's big. There's a lot of things running in memory, and it uses a lot of footprint, a lot of CPU. OpenShift needs 16 gig of RAM to idle.
Yeah, but it's OpenShift.
Right? So I'm like, okay, cool. So how do I get Kubernetes everywhere? If the entire ecosystem is saying, I'm going to ship software as operators or Helm charts, if all of the tooling from the vendors down on the trade floor here is powered or powering the Kubernetes API, how do I get it everywhere? How can I get Kubernetes running in the same memory footprint as Docker and Podman? And that's what we did with Kube Solo. So Kube Solo is Kubernetes. It runs in 200 megabytes of RAM.
So there's some magic there.
There's some magic there. And the magic is in the name, Solo there, because it is only a single node. So it's not a cluster. It is a single node cluster. So it lets you replace Docker or Podman, which aren't clustering anyway. We're going to ignore Swarm for now, but just Docker and Podman. It lets you replace that with Kube Solo, so now you can run Kubernetes in the same memory footprint. And how do we get it so low? There's no quorum, because there's no need for a cluster. There's no scheduler, because there's nothing to schedule. It all just runs on the host. And so it is full Kubernetes. You've got RBAC, you've got operator support, you've got Helm.
The Kubernetes API?
It's Kubernetes. We're not emulating. It's just Kubernetes.
And are you also running an etcd then?
No, there's no quorum.
Oh, yeah.
So basically, it's the Kubernetes API and the kubelet without any kind of quorum. And so all of the cluster quorum things just get a OK command, and it's all there.
So what problem does this solve if you look at like edge cases or in your practice?
Kubernetes at the edge. So if you think about what we designed this for, it was for the IoT world.
Exactly.
So
yeah, I can see that.
Now with AI everywhere, you want AI ingest on cameras. You've got the self-service shopping kiosks everywhere with fraud and theft prevention cameras on them. They're using AI ingest to compare. You want to deploy those as a containerized workload. Well, now you can run Kubernetes on them, and you're not wasting RAM. You can run comfortably on an Nvidia Jetson, and you've got all of that RAM capacity for your workload, not wasting resource to idle Kubernetes. What for? So basically, we say that there's a triangle, and on the kubesolo.io website, you can see the triangle. You've got cloud and data center, you've got edge, and then you've got far edge. And far edge is actually the device edge. So traffic cameras, surveillance cameras, the AI systems on tractors.
And that's also a talk, of course. They're gonna bring more AI to the edge, because if you have image recognition, you can do that on your device and just send the results to the data center, and then that's much easier to send all those images or the complete stream of video to the data center. It saves bandwidth.
True.
Well, it's not only bandwidth, but it's also real time. Like if you think about a self-service or a self-checkout in a shop, right? If you have two things of cola, one Coke and one not Coke, you can scan the not Coke and put the real Coke in your bag, or you can do it with cheap meat and expensive meat, right? It happens all the time. And so these cameras are watching, looking for the swapping of things. They need to immediately alert you. They can't wait for the image to go back to some cloud service to be rendered. Okay, there's a fraudulent swap here. Alert. Meanwhile, the customer's left the store. You need to be able to do on-device, instantaneous. There's a switch here. Bang,
especially
bang,
if there's like a SaaS solution behind those cameras that it goes to the internet, and when the connection is down,
that's also
you lose all the capabilities.
Remember the Chick-fil-A story?
Yeah.
But also one of the ones that I mentioned a few times, because it's the coolest use case I've ever seen, is John Deere and the tractors. They've got a boom in front of the tractor with cameras. They've got a boom at the back of the camera with lasers. And as the tractor drives on the field, the camera is looking for weeds. And as the tractor drives over, it's already detected the weed and shoots the laser at the weed. And so you've only got a split second, because that tractor's moving, to read the image, figure out what it is, and then fire the laser behind you. That stuff, there's no way that you could send it from a tractor in a farm field over 4G to a cloud service to make a decision to come back again to the tractor and fire the laser. You can't do it.
No.
This is designed to power those kind of use cases.
But normally, we just install that on the machine as a good old software, and you're saying...
But then how do you update it? How do you...
Yeah, we want to run that in containers, and we have to manage those containers. So we need Kubernetes, of course.
because it's a scale problem. Like if you think about where you use Kubernetes in the data center, a large scale deployment might have been a few hundred clusters. Well, in an IoT world, you're talking about hundreds of thousands of devices.
Yeah.
You can't upgrade that. It's like the people who paint bridges. By the time you finish painting the bridge, you've got to start again. So if you had physically installed software and you have to go and visit a tractor or find some way to get to it, and oh my goodness, you'll never finish.
Yeah, but there should be some trade-offs, right? If you remove, make it a single node, there should be. Aren't there any? are there any trade-offs? Because
There's no less resilient than Docker on the standalone device, or if you just installed software on the device. I mean, yes, it's not highly available. It's not a cluster, but you wouldn't have a cluster anyway. But what we're actually seeing where Kube Solo is being implemented, they're taking the airline control system, the ABC system. So you have 3 standalone clusters, your application running 3 times, and an external load balancer or arbitrator determining, okay, is my application alive? Because if you think about a normal Kubernetes cluster, a 3-node cluster, you have a single point of failure, the cluster.
That cluster, right?
The cluster. Etsy fails, core DNS fails, and now it's offline. If you have 3 discrete clusters with the application running 3 times, the chance of your application going offline, pretty slim. So, and that's where Kube Solo is very good, is with this kind of airline or airplane control system, an ABC.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
Are you also looking like solutions like the Cordent? Is that also something similar or from Mirantis? They also
different.
Different.
Yeah.
Okay.
Yeah, different.
Okay.
I mean, other approaches to this are Kube Edge, where you have control planes in the cloud and workers out in the field, and you manage it as one single giant virtual cluster that requires relatively persistent networking.
Yeah.
Kube Solo is completely standalone. Everything is self-arbitrating. You can lose internet for a week if you want, no problem.
Oh, right. Yeah, I was thinking I was reading something about Cordent and doing something with the AI, so I was trying to see if there's a hook over
Something with AI.
Something with AI.
Everybody's doing something with AI.
Yeah. Well,
So, and you're following Kubernetes, or you're using the Kubernetes binary?
It's Kubernetes. It's not an emulator. It's literally Kubernetes, and all we're doing is taking the Kubernetes code, removing the quorum and the scheduler. We have our own little micro scheduler, which is a shim in between. But that's it. It's just Kubernetes. So it's in lockstep with Kubernetes releases.
Yeah, I was thinking you need a scheduler of things, or you can put it in the etcd Kubernetes.
But there's no Etsy. So for those developers out there who really want to see that, it's 100% open source anyway. So you can go see the code and see what we're doing. It's pretty neat.
Cool. Yeah.
it doesn't happen a lot that you run out of questions.
No, I was just thinking.
But he also answered a lot of questions in his stories.
I was thinking
he does this often, so he knows what questions he can get.
This isn't my first rodeo.
I was just thinking. So the scenarios are tractors, everything on the edge, a far edge.
Yeah, that's an interesting thing because that's the first time I remember hearing the far edge as a term. Normally, when people talk about edge, it's just the edge, like drones flying through a field.
Drones are also the far edge.
Oh, that's also the far edge. Okay.
So the far edge ordinarily has 32, maybe 64, but 1 or 2 gig of RAM max. Yeah, most of the PLCs. I mean, with Industry 4 now, you've got soft PLCs. They're running Industry 4 software, which runs in containers. Those things have 512 mega RAM and a 32 gig SD card in them.
Raspberry Pi 1.
How famous is it to have your SD cards burning out from Kubernetes with Etsy constantly writing to the SD card burning out? Kube Solo doesn't do that. There's no quorum. It's not thrashing a disk. It doesn't burn out your SD card. So there's a whole bunch of benefits to it.
If you think about a downside, what is the biggest downside running Kube Solo?
Because it is a single node, you need to have a multi-cluster management solution. So hence Portainer.
Portainer.
Or there are dozens and dozens of other tools out there. Again, Open Cluster Management from CNCF. There's a whole bunch of other tools to do multi-cluster management. It supports Argo, it supports Flux. It's just Kubernetes, but you need a way to manage a large fleet of Kubernetes clusters.
Yeah.
You have to.
And do you think we're going to a more simplifying way of using Kubernetes on using this kind of solutions?
It's a single binary.
Yeah.
We've already offlined, or we embed in the images for like pause container and other things. So the thing is designed to run air gapped, and it's incredibly simple to triage because there's no moving parts to break. It's just a single self enclosed binary.
Yeah, but the answers we got when we asked our final questions, where we are going to later, is that we want to see like the layers of abstractions removed from that. It's going to be easier to be using Kubernetes in the future. Is that also your vision, looking at like a Portainer or a Kube Solo, using it in that way? My
whole goal with Portainer is to make Kubernetes intuitive. Now, realistically, do I think you can make Kubernetes simple? No. Kubernetes is quite a complicated beast. Now, you can abstract and therefore make it much more intuitive. And that's what we're doing in Portainer, is we're making Kubernetes available to the IT generalist.
Right.
So if you think about everyone on the trade floor downstairs right now, right, all their tooling is angled towards DevOps, platform engineering specialists, highly trained, expensive, massively in demand specialists. Okay, cool. That's about 20% of enterprises worldwide can afford and retain those type of people. What does everyone else use? What tooling out there is designed for the IT generalist, the VMware ex-professional, the Microsoft professional? What do they use? They don't use any tools down there. And that's what we have built Portainer for. It's like, how do we make Portainer feel like a VMware vCenter experience, like a Microsoft Management Console experience? So all of these guys and girls, IT generalists, can be brought into the Kubernetes ecosystem without having to go and retrain them. Yeah, if skill and experience is a precursor to adoption of Kubernetes, that's a problem.
Yeah.
So we're designed to make it far more accessible. And would I go so far to say that an organization using Portainer needs no one who knows Kubernetes? Absolutely not. That's stupid. But you might need one person who knows what they're doing, and that one person can now enable a huge team of non-experts through Portainer. But if they didn't have Portainer and they're using a whole bunch of CNCF tooling, they will have to go and retrain their people.
Yeah, I think it's an interesting solution, because also a thing that comes to mind, because we have them later on today, I think, or tomorrow. Yeah. Today, Avasa. You're familiar with them? They are because they say you don't need Kubernetes. So and they also are looking at the cases at the edge. So yeah, I'm interested to see if. What question should we ask them from your point of view?
Because I can tell you categorically.
Because that is interesting, because I think you're moving in the same space, but you're using Kubernetes at its core.
Yeah.
But they say we don't. So there is like there is something there that is interesting.
Here's the thing, right? Kubernetes has dominated the ecosystem. You can't fight against it. It's everywhere. I don't know how many vendors are on the trade floor downstairs. 500? More, maybe? All of their products designed and built for the Kubernetes API. Backup, recovery, DR, security, monitoring, observability, alerting. It's all built around Kubernetes. You can't fight against it. So how do you make Kubernetes everywhere? To try and say you don't need... not everyone needs Kubernetes, let's be honest.
True.
But if the ecosystem...
we wish it was so.
Correct. But if the ecosystem is standardized on the Kubernetes API as a construct to integrate tooling, fighting against that is a losing battle. So my whole philosophy with Kube Solo is, okay, cool. Let's give the Kubernetes API, but make Kubernetes as easy to use as Docker and Podman. Because if you think about Avassa, and I got a lot of time for them, right? It's their own language. They're not using Docker Compose. They're not using Podman Compose. And they're not using Kubernetes, YAML, or Helm charts. It's their own thing.
Yeah.
Hang on. But the ecosystem is standardized on a Helm chart or a Kubernetes manifest or an operator as the way. So now how does an application vendor support their software on that stack? How? It's something bespoke. My thing is, well, just don't do that. Let's just give them what they want, which is the Kubernetes API raw and unfiltered, out at the edge, but in a lean and mean, efficient way.
Okay, yeah, interesting. Something we can take into that conversation also.
We'll do.
Yeah, I think we're ready for the final question.
Yeah.
Do you have the honors?
Oh, yeah. We always ask our final question, how do you see the future of Kubernetes in the broadest way possible?
So I don't know if you guys have had much experience with virtualization, right? But in the early days of VMware, and I was like 20 years as a VMware guy, right? So in the early days of VMware, I made a lot of money off VMware, right? It was a specialist thing. You had those VCDXs out there who were, swanning around saying, "Oh, this is amazing."
Mm-hmm.
What happened to that VMware technology?
Broadcom.
No, before that. Right? Let's not go there. So what happened? Its adoption was quite slow. Now, how did adoption take off? They got humans as a barrier to adoption out of the equation, right? vCenter and all of the install wizards. If you needed a highly trained, certified professional, then all of a sudden you've now got a bottleneck to software adoption. The humans are a bottleneck. And so how did VMware go from 5, 10, 20, 50% market penetration to 90, 95%? They got humans out of the equation and used a whole bunch of wizards and onboarding installers. That, I think, is the future for Kubernetes. It has to focus on how do you go from nothing to a production-ready environment in an afternoon, not 6 months.
Almost like a next finish.
But is that only in the Kubernetes environment? I think that, and I'm gonna contradict you. The application, the developer's application needs to do more steps. That needs to be easier, because if you run your application on Kubernetes, you know what you have to do to run it properly.
Yeah, correct. But still think back to the overall enterprise landscape, right? How many enterprises out there design and build and support their own software exclusively? A small subset. Let's say 20, 30% of all enterprises design, build, and run their own software. What does everyone else do? They buy software from ISVs. Now, the ISV world absolutely will go and hire and specialize. We'll get Kubernetes experts who will build Helm charts. Now, why Kubernetes operators now so popular? Because an operator is a way of teaching Kubernetes how to deploy the application perfectly every single time. Now, who writes the operator? The ISV. So when you use an operator to deploy your software in Kubernetes, you are getting an exact photocopy of what the ISV wanted. So that removes a lot of the complexity in deploying an application on Kubernetes from an ISV. You say, here's my operator. So Kubernetes, deploy my operator. Hey, operator, deploy me a database or deploy me something. And the operator knows how to do it. That removes the deployment complexity. So ISVs will still have to deal with the complexity, but enterprises who deploy their software won't. And so if you can say, I want to remove the infrastructure complexity, and now my ISVs have removed the application deployment complexity, now it's everywhere.
Okay, cool.
Something to think about.
Yeah, something to think. I like something to think about. So thank you very much.
Yeah.
No problem.
Thank you very much for this
Thanks for having
conversation. Yeah.
Yeah.
And until next time.
Yeah.
Okay. See ya.
Bye bye.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.